This video will explain what y-intercepts and x-intercepts are and how to find them. We start with this squiggly green curve on a graph, x-axis, y-axis. This is not a function, by the way. Y is not a function of x, and that comes up later in this video. But we start with the most general thing, which is a graph, a relation between two variables, x and y, and it's been graphed. The relation has been graphed. And a y-intercept is anywhere where this green graph intersects the y-axis, and an x-intercept is anywhere where the green graph intersects the x-axis. So let's start with the y-intercepts. How many are there? There are 3, here, here, and here. And let's just say that this one looks like it's going through the origin, so those coordinates are 0, 0. This one here, we'll say that's about 4, so that's 0, 4 as its coordinate. And this one here is maybe -3, so that's 0, -3. Look what these three have in common. They have different y values, of course, a negative, a positive, and a 0, but they all have the same x value, and that x value is always 0, because on the y-axis, that's where x equals 0. So y-intercept is wherever x equals 0. Wherever on the green curve the value of x is 0, those are y-intercepts. And then you can see where this is going. X-intercepts are here, 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 and here. There are 5 on this graph. And we've got 0, 0 again. And this one here might be 4, 0. And this might be about 9, 0. This one's about -4, 0. And this one's about -9, 0. And you can see what all 5 have in common. They have different x values, but they all have the same y value, and that y value has to be 0, because at the x-axis, everywhere on the x-axis, the value of y is 0. So an x-intercept is wherever your curve has a value where y equals 0. That's what makes an x-intercept. Okay? This is true for all relations between x and y. All graphs you can make, not just, quote, functions. Okay? That's the most general case. Okay, but for now, since the large majority of what you do in high school math is where y is a function of x. So for now, we'll only look at where relations where y is a function of x. Here, y is not a function of x, but they still relate to each other. This is called a relation. A relation is any equation that has x's and y's in it, or any two variables, relation between two variables. For now, we're only going to look at a special subset of relations where y is a function of x. And what that means is you can get y on one side by itself, and then a bunch of stuff on the other side that could just be the single letter x or even a number. But it could be as complicated as you want, but the only letter on the right-hand side will be the letter x, and it can occur in any combination with other numbers and functions, like sine of x, x squared, anything like that, and x can occur any number of times, but no y's on this side. And on this side, only a y, a single y, no exponent, nothing else, just a bare letter y and nothing else on the left. When we arrange it like that, we say y is a function of x. We call the variable by itself on the left dependent, which in math classes is usually y, and in real life is almost never y. It's usually like t for temperature, or delta x for change in position, or v for velocity. And here on this side, the letter that's enmeshed in all of this expressions over here is called the independent variable, and in real life that's sometimes x, but it's much more commonly t for time. In real life, that's the most common independent variable is t. Here's some examples. You can take a look at those, and you can pause this video at any time. That's why I'm trying to talk fast and why everything's pre-written, because I know you can pause it if you need to look things over. In each one of these, you'll see y is all by itself on the left, and there are no y's on the right. Y has absolutely nothing else with it, but on the right-hand side, you can have any combination of things with x's you want. Okay. All right. What this leads to is ways of expressing that equation. You can make a table, and when we make a table, we put the independent variable on the left side of the table, and we put the dependent variable on the right side of the table, no matter what they are. So for example, if x is a function of t, t for time would go here, and x would go here. Okay? So it doesn't always have to be x and y. It depends on what's the independent variable and the dependent variable. Independent variable first, you can tell which is independent by being the one in here. Dependent's the one by itself on one side. When we make a graph, we put the dependent variable on the vertical axis and independent on the horizontal axis. This is not always x, this is not always y. In fact, very, very commonly, if you take physics, this will be x, and this will be t for time. So it's a bad idea in your science classes to call this the x-axis and this the y-axis. What you want to do is say the horizontal axis and the vertical axis, or independent variable and dependent variable, like that. Because look how silly that would be if we're plotting x for position versus t time. We can't say we have x on the y-axis and t on the x-axis. That doesn't make any sense. This is the x-axis, right? So it's better not to call these the x and y-axis in a science class. All right, so dependent variable there, independent variable there, and there we go. There's our graph. Okay. Since functions are the way they are, since they have the dependent variable all by itself on the left and not occurring at all on the right, that means when you make a table, anytime you pick a number for y, you're going to get exactly one number, or a number for x, that will result in exactly one number for y, because you have this single function and it cranks out a single number. That's called one-to-one mapping. And so for each value or number, value in math means number. So by the way, digression, when they say to evaluate something in a math book or test, that means your final answer is supposed to be a number. That's what the word evaluate means. And if your teacher writes a question where they say evaluate something and the answer has letters, then your teacher doesn't understand what the word evaluate means. So for each value we plug in for x, there is a unique y. Okay? The consequences of that on a graph are that if you pick any value of x, there can only be a single unique y, which means there can only be one. There can be only one. If you've ever seen the movie Highlander, there can be only one. All right? That's if a function doesn't pass that, we'll put a function here in a different color. Okay, let's say brown. Let's see if it's not a function. Let's see if a relation, a graph that looks like this. Okay, that cannot be y as a function of x, because for this value of x, I have 1, 2, 3, maybe even 4 values of y. That's called failing the vertical line test. The way you do the vertical line test is you look at your function, look at your graph, and if you can do this, and no matter where you do it, you hit your graph only once, then y is a function of x. If there's anywhere you can do it, like look at the brown curve now, and you hit your graph more than once, then y is not a function of x. So that's called passing the vertical line test. A graph is a function, the vertical variable is a function of the horizontal variable if every single vertical line hits the graph at most once. All right, now that we have the ideas of intercepts and what makes something an intercept, the value it has, and the idea of a function, we're ready to find intercepts. Okay, to find the y-intercept, we saw earlier on the very first idea we had, the very first page, the y-intercept is where x equals 0. And the x-intercept is where y equals 0. So to find the y-intercept, you replace x with the number 0. And since you're in function form, we're limiting this video only to relations where y is a function of x. That will immediately give you y equals some number, and that number is the y-intercept. So let's do some examples here. Replace x with 0, you get y equals 0. That's the intercept, the origin. Okay? Here you replace x with 0, you get 0 minus 16, y equals negative 16. That's the intercept. Officially, that would be written 0, negative 16 as the point. Okay? This graph, by the way, looks like this. And there it is. Okay? This one here, replace x with 0, and you get 0 minus 0, y equals 0, goes through the origin again. And this graph looks like this. Let's see, there, near the origin, negative slant, becomes a positive parabola, upward parabola, so there. Okay, there's the y-intercept. All right, and then finally, this one we replace x with 0, 0, 0, 6, and we get y equals 6. Here's what this graph looks like. Y-intercept is 6. Negative there. It's down like this. Upward parabola like that. There's your y-intercept. All right, so that's how we find the y-intercept. It would be 0, 6. And you'll notice every time a point is a y-intercept, the x-coordinate is 0. The first digit of its coordinate is 0. All right, now, this said to find the y-intercept because there can only be one if something is a function. Otherwise, it would fail the vertical line test. To find all x-intercepts, oh, that means there can be more than one x-intercept. There can be, but it doesn't have to be. Just as before, a y-intercept had x equals 0, the x-intercept has y equals 0. But then you're going to have to solve for x. There might be more than one. All right, so let's do that. Okay, what do? Replace y with 0. 0 equals negative 1/2 x to the 4th. Multiply both sides by, or divide by negative 2, by negative 1/2, multiply by negative 2. Doesn't matter. You're going to wind up with x equals 0. And so this graph goes through the origin, and that's the only x-intercept. For this one here, replace y with 0. 0 equals x squared minus 16. X squared equals 16. Or if you like to do x plus 4 times x minus 4 equals 0. Whichever way is fine, as long as you get x equals negative 4 and x equals positive 4. All right, the graph looks like this. And there are those intercepts. Negative 4, 0 and 4, 0. Notice they both have y equals 0, of course, because they're intersecting the x-axis. 2 x-intercepts. Okay, another example. This one here, we have 0 equals x squared minus 3x. There are different ways to figure out what the x's are. I'm going to use factoring. Factor out an x and get x times x minus 3 equals 0. This is of the form a times b equals 0, which means a equals 0 or b equals 0, so I get x equals 0. And the other solution is x minus 3 equals 0, so x equals 3. All right, so what that gives me is 0, 0, this goes through the origin, and 3, 0. Looks like this. All right, we come to the last one. Replace y with 0, because we're looking for x-intercepts. Get this. How do you solve this? Well, it's a quadratic with all three terms. An algebra 1 approach of like moving the 6 over and trying to square root that, that's not going to work. You have one of three choices. You can try factoring. You can try the quadratic formula, or you can complete the square. I made this one up so that it factors x minus 2 times x minus 3 equals 0. All right, and that's of the form again, a times b equals 0. So this is 0 or that is 0. X minus 2 equals 0. X minus 3 equals 0. I get x equals 2 and x equals 3. This graph looks like this. Has a y-intercept of 6. Near the y-intercept, when x is small, it has a slope of negative 5, like a line with a slope of negative 5. As you move away from that, as x gets bigger and bigger, it looks more like an upward positive parabola. We found it has 2 x-intercepts. So it goes like that. This graph isn't as smooth as it should be. There are the 2 x-intercepts. This one is 2, 0, and this one is 3, 0. Of course, you can find the x-intercepts first, and then that can help you do a graph. Finally, we have one special example to look at. Y equals 4 times x to the negative 2. All right, what this means is y equals 4 times 1 over x squared. So let's try finding the intercepts. Let's start with the y-intercept. Y-intercept means x equals 0. Oops, you can't do that. Cannot do. Impossible. Not allowed. Okay, so let's move on to trying to do the x-intercept. X-intercept means y equals 0. So you get 0 equals 4 over x squared. Okay, and I have a fraction, and I'm trying to make it equal to 0. Well, the only way a fraction can be 0 is if the top equals 0 and the bottom does not equal 0. The top here is 4. It cannot equal 0, so there are no x-intercepts. So this graph has no y-intercepts and no x-intercepts, and that's okay. There doesn't always have to be an x-intercept or a y-intercept. You might have one, you might have the other, you might have both, or you might not have either one of them.